Hi everyone and welcome back to another episode of Let's Explore, where today I'm going to be looking at Python once again. This is kind of a continuation from episode 1 where we did some random number generation to select some lottery numbers. This time I'm going to be doing a game based on a deck of cards. This is going to be called Python Play Your Cards Right. If you've ever seen the game show, this is where, or if you haven't seen the game show, it's a game where you shuffle a load of cards, you turn one over, and then you have to predict whether the next one is going to be higher or lower. So there's going to be a few programming challenges to make this happen. Again, just a little bit about my background. I know a bit of Python. I know enough that in conjunction with Google, I can just about get the job done. Hopefully that's what I'll demonstrate today and show off the fact that as a scripting language, Python is really useful for just being able to just achieve little aspects of coding that you might want to do. And as a bonus mission, I'm going to try and play the game at the end and try and get 10 cards in a row correct. And we'll see how that goes. Let us begin by just opening up the Python IDE. I use the default idle. I'm going to actually look at some other IDEs in a future episode because I do Python a lot, and I'm still drawn back to this kind of the clean structure of the native framework. But I'm going to begin just by writing out the things that I think I want to do. This is kind of just a little bit of pre-planning. What I want to do is create a deck of cards, shuffle deck. Before I start adding the user input, I'm just going to write the code that write function to detect higher or lower, allow user input, and then check if user input is correct. Just going to leave that at the top of the script just as a reminder to keep an eye on what I'm trying to do. I'm going to try and do it quite fast and loose to begin with. Like I did in episode 1, I'm going to try and do something that works, and then if there's time, I might go back and refactor it. If I don't get time on this episode to refactor it, then I'll go back and do it afterwards, and there'll be a link in the description to go and see the nicely refactored version. But let's get the show on the road. So the first thing we want to do is create a function called createDeck. And what are we going to do in here? Well, we need to create 4 suits with 13 cards in each one. So you've got ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. In Play Your Cards Right, an ace is high. So what I'm going to do, I want to make this comparison easier for myself later. So I'm going to begin by just giving the cards numbers. And I'll show you what I'm going to do. Let's do a loop for suit in suits. I'll create myself a list of the suits. I'll just do it with spades, hearts, diamonds, clubs. I'm going to make this nicer later. I think what I might come and do is use like the ASCII symbol to the 4 suits. But just to get things going, there's a list of suits, and for each one, for card number in range. Now what I'm going to do is 2 to 15. So the lowest card in Play Your Cards Right is a 2. And then all the way up to 10 is obviously the number cards. Then 11 will be jack, 12 will be queen, 13 king, 14 ace. And I think when you're doing a Python range, it excludes the top number. So I think that will give us everything, but we'll do a print in a second to find out. Let's create ourselves a placeholder for a deck, an empty array for a deck. And then we'll do deck. Is it push? I had the exact same problem in episode 1. Or is it? No, it's append. I think I made that mistake in episode 1, and it is append. And we'll put the value card number. So as we're going through this loop, I think we need to convert it to a string. Nope. So put the card number and then the letter of the suit after it. So I think that will go through and go 2S, 3S, 4S, etc, etc, etc. And the easiest way to find out would do return deck at the end. So when you call this function, it creates the deck and then sends it back. But this will be completely unsorted to begin with. Or sorry, sorted in fact. We haven't shuffled it yet. I think I can then just do print create deck. And if I run this, okay, that's annoying. Why did it print the name of the function? Let me work out the really obvious thing that I've done wrong here. Do I need to use brackets to show I mean create deck the function rather than something else? That looks like it's done it. There we go. 2S, 3S, 4S. So it goes all the way up to 14, which will be the ace of spades. Then back down to the 2 of hearts, and so on and so forth. That's basically what we want. That is a deck. What we can also then do, hopefully really quickly. You know what, I'm going to put the shuffle deck in a separate function just so that we can choose whether or not we want to shuffle a deck. Pass in a deck. And then we're going to need to import the random library. I'm going to try and do this from memory. I might have to Google it if I get it wrong. And then return random.shuffle brackets deck. I think what this should do is take in the deck. Deck is create deck. So this is where the actual script starts. First of all, create a deck and store it in the variable deck. And then, just for visibility, I'll put it into a separate variable. Shuffle deck equals call the function with the deck. Then if we print shuffled deck, hopefully we'll see we have the same output, but now the cards are in a shuffled state. Nope, we get none. What did I get wrong there? Let's put some debugging in. Let's print deck first of all, make sure we stored the deck correctly in the first place. We did. There is an unshuffled deck. Shuffled deck equals shuffle a deck. We go into the I'm going to search for what the Python random shuffle does. Probably made a really glaring error. Rendering from W3 schools, but okay, it looks like you called the random.shuffle on the original variable, and it modifies the original variable. So rather than trying to return that, I think what I need to do is just do random shuffle deck and then return deck again. Let's have a look. There we go. Ignore, obviously we're printing out the unshuffled one first, which is there, but then after that we are printing out the shuffle deck, which we haven't checked to make sure that's a one-to-one mapping, but you can assume as it's shuffled, it's not lost any cards along the way. It's a built-in function. It's going to be doing what it should. So, collapse some of this code down a bit now. What we have is not refactored, but we've got a shuffled deck. What I want to do now is write a function that can test whether a card is higher or lower, because we're going to need that to do our check to see whether the user is correct. So I'm going to write a function called higher or lower, which takes two cards as input, this card and previous card. And then come back here in 2 seconds to do some stuff. But let's get those cards into that function first of all. So we've got a shuffled deck. So for card, in fact I'll call it this card, for this card in shuffled deck. So it goes over this for every single card in the deck. Now, first time we come into this function, there won't be a previous card because it's the first time. So I'm going to set up a variable called previous card equals none. And then in this function, we'll say if previous card is not none, then we know this is our second time around the loop. Again, to do, I'll come back to that. What I'm just going to do is talk myself through the first time through this loop. So the first time through, I don't need to call higher or lower because we're not doing that. We're just going to print the name of the card. So print this card. And I'm going to add to the end of that, not higher or lower. Which means I'm going to need an else on this. Let's do the none case first because we're only going to do this one time through. So if previous card is none, just print this card, not higher or lower. Otherwise, we're on another time through, and I'll write that code in a second. And then getting ready for going around the loop again. At the end of this loop, we want to go previous card equals this card. So it means as soon as we restart this loop, we know that the card we've just used was the previous card. But assuming we're in this else block, it means we're in the second loop round here or after. So now we can say higher or lower, and we can send these two values in because we've created them in this loop. And in here we will say if... Okay, now if you remember, we've got the letter of the suit applied to the end. Now the reason why I did one letter suits is because this means if we take the last character off, we know what the number of the card is. I've just noticed another to-do that I'm going to add for myself now, which I'll do down here, just as a reminder at the end. Convert 11 to 14 into Jack to Ace. For now, we'll just keep printing out the numbers, but we're dealing with cards here, so we should make them really look like cards. Higher or lower? This card number equals... now what I want to do is take the last character off the string, and things like string operations I know is always something like trim, but I'm going to Google it to check. Trim last character of string. Just use a slice. Let's see if Stack Overflow agrees. Oh, that was a Stack Overflow. Okay, so if you use an array and do colon and then -1, it will take the last one off. Let's confirm that. That should be just the number bit because it'll take the last character off, and previous card number equals previous card, but the same thing. Also, we want to turn them into numbers so that we can do higher or lower comparisons. And I think we just need to put an int around it to say, take what we've got here and make it into a number. Now, if we've not validated our types or we've got bad input, this code might fall over because it'll go, this isn't an integer, but we're not letting the user modify the array of cards, so we should be okay. We'll find out in a second. Then again, I'm just going to do a very wordy version of this that will probably collapse down nicely later. But if this card number is higher than previous card number, print, firstly this card, like we did in the other array. I just pointed at the screen like you can see my finger pointing. This card plus, we're saying this one is higher than the previous one, so brackets higher. So this isn't letting the user input anything first, this is just checking the logic of whether we can detect higher or lower. Again, is it else if or is it else space if? Some languages it's elif. Seems to like elif. Let's see if that's right. It's higher than this card number. Print this card. And this time we're saying this one is lower. For a bit of code brevity, rather than printing, I'm just going to do return. So we just send straight back from this function the string we want to send. So return this card lower. And because we've already returned in both those two cases, we now know that if we make it to this line, it's not bigger or smaller, it must be the same. So return this card plus brackets same. Then we turn this else down here into print, which means it will call the function and then it will return that string and it will print it out, I hope. Now we've actually written quite a lot of code in one go there. Chances of this working first time, relatively slim. But let's have a look. Okay, it's doing things. Let's go to the start and walk through the first few cards. So first time through, we've got the 13 of hearts, which is a king of hearts, and it's not higher or lower because it's the first time. Next one was the same. What are the odds of the first two being the same? Doing odds in head. We've already got one of them, so 3 and 51 is the odds of that happening. I'm very good at making unlikely things happen. Next one was a 4, which is lower. Next one's a 5, which is higher. 11 higher. 8 lower. 5 lower. 13 higher. It's looking like the higher-lower detection is working. Did we get any more sames along the way? Yeah, a 6 followed by a 6, and then a 2 followed by a 2. So the detection of whether cards are higher, lower, or the same is working, which means we can move on to user input. Now, I've not done anything with user input in Python scripts for a long time, so this one, I'm going to be winging it a bit. Now, I'm going to build the user input into the same loop. So now we're imagining we're actually doing a game. This first time through the loop, I'm going to write first card is, so this is kind of a hint to the user, so they can get ready to start guessing. First card is this. And then we want to say, this is where we want the user to guess what the next card is going to be. So, next card, prediction. Now I think the keyword, is it input or is it raw input? My interface seems to want just input. Read a string from a standard input. I'm just going to check this is even going to work. Before I start actually doing anything with the prediction, I'm just going to say higher or lower. And as a hint, I'm just going to say H or L. Just ask the user to type a H or L. We'll do better. I'll actually do some validation on this in the future. I just want to make sure the thing will actually work. And then just to check it's working, I'm going to just do print next card prediction just to make sure that I've successfully taken the user input and put it into it. Let's run that and see if it's doing anything we might want it to do. Oh, that's gone bad. I have an extra quote mark that I didn't need. That was just a syntax error. First card is 12, higher or lower. I'm going to type X because it actually doesn't matter what it is. And it writes X. So that's proved that it's taken the user input and saved it into the next card prediction. I'm going to stop this program for now. So I'm going to add to my to-dos. To do validate input is H or L. We could do that nicely at the end if we get time. Otherwise I'll do it off camera. So what this means is next time we come around here and in the else, I am going to change the higher or lower to just return one letter. And this will make sense in a second. So if it's higher, return a H. If it's lower, return an L. If it's smaller, return an S. Oh, sorry, if it's the same, return an S. Now again, this is where we have things in scripts that we call magic numbers or magic variables. It's not great to have these embedded deep within your script. It's normally good to do those things called constants, which you keep at the top of the script, and then you just reference the constant, so that if you have to suddenly start changing your higher to your lowers, or you want to change H to something else, you can do it in one place. Why have you indented that? That's not helpful, idle. To do convert magic numbers letters to constants. But this means that now, if I put actual higher lower equals that thing, now we're in here, we have two values. We have a H, L or S in actual higher lower based on what it was, and we also have next card prediction, which will be either H or L if we validated the input properly, and now we can actually evaluate whether the user got the prediction correct. So if next card prediction equals actual higher lower, print this card, which is, it's literally in this card, plus correct. Just to tell the user they got their card correct. We'll come back and make the wording and stuff nicer later. Let's get the logic right first. So if they didn't get it correct, they got it wrong. And we'll put print this card, wrong, game over. It won't actually end the game yet, but again, we'll do the game elements in a minute. This will just prove whether we got it. We've got the logic working. Again, I did a lot in one go there, probably more than I should have. So the problem here now is if something goes wrong, it might be hard to pin down where my logic's gone wrong because I did too much at once. Invalid syntax. Highlight where I got my syntax wrong. Okay. If you're doing a comparison, you do to do a double equals. A single equals means it actually tries to assign it. And then if you have double equals. First card is 12. That's quite high. Let's go lower. And it's a 6, which is correct. Let's try and get it wrong. Let's keep going lower because odds are we'll be wrong. 10. Wrong, game over. Okay, so the logic there is working. Let's go back to my list of things at the top. So we've created a deck of cards and shuffled it. We've written the function to detect whether it's high or low. We allow user input. We check if user input is correct. So we're technically done, but it's still very janky. So things I'm going to do now are, I said I want to try and get 10 in a row correct. So let's write something that tracks how many cards we've got right. So I'm going to set winning streak equals 0. So if the prediction is correct, add 1 to winning streak. And when the user eventually loses, I'm going to print it on a separate line. I'm going to do print game over. You got plus the string version of the number winning streak in a row. Now, the easiest way to... I should probably just throw in a thing to stop the game now. I think... Does Python have a quit keyword? Python stop execution. Exit is the keyword to exit the script altogether. So if I just do an exit there, this means the script will just stop running when the user eventually gets it wrong. Now, I've spotted a potential bug here, which is in the unlikely event that the user gets all the way to the end of the pack, it won't print any kind of game over message, it will just stop running. So what I want actually is, at the end of this function, which is getting quite large, this is actually in a function. I should definitely refactor some of this code because it's getting a bit long. But if we make it all the way down to where my cursor is here, this means we've got through the entire pack and we didn't get anything wrong. Now the chances of that ever happening in real life are really slim because, for example, if you get two cards the same in a row, it's game over instantly. So you've got to dodge that straight away and get every single prediction right. But let's put a message here just in case. Print, you got every card right. You are a genius. This is an edge case that will never be seen in the wild. We may now actually have a working game. I want to come back and do these refactors in a second, but let's just play one run through of the game, if my code works. Start with a 2, the lowest card possible. Let's go higher. 10. Odds are it should be lower, so lower. 7. That's in the middle. I'm going to go higher again. It's 2 7s. You got 2 in a row. No, I didn't. I got 3 in a row. No, I didn't. I got 2 correct and then 1 wrong. So 2 in a row is correct. Exit actually tells Python actually complains. I want it to stop harder than that. So maybe exit isn't the keyword I want to use. You know what? I'll make that nicer later. Exit and quit do what they want. But they should only be using the interpreter ID in the console. Doesn't work in scripts. Blah, 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 blah. Okay, so actually this isn't the way to do it. How am I going to do this? I'm not going to worry about it for now because it's not fun for you to watch me try and work out how to do that. So to do, make script exit, in quotes, more elegantly. Let's do some nice things. I'm just going to do this, converting the cards into actual cards to finish off with. So the first thing I'm going to do is I'm going to take the spades, hearts, diamonds, club. I'm going to find what the ASCII symbols are for those. ASCII club symbol. There we go. I was hoping it was going to find all of the relevant ones next to it. There we go. There are 4 black suits. They are Unicode characters. Can I copy it? Why are you not letting me copy it, you naughty web page? Okay. So, there's a spade. There's a heart. There's a club. And there's a diamond. And the final thing to do is make the 11 to 14 into Jack, Queen, King, Ace. Now, where do we actually print the cards out? It's just where we say this card. So we want to leave the array alone because we like the fact that there are numbers in the array. But basically, anytime we print the card out, we want to be able to print a nice version. So I'm going to create a function called print card number, which takes a card. Let's reduce it down just to the number again. So I'm going to copy this code. Now, anytime you copy and paste the same code over and over again, that's usually points to where you can do another refactor on something later. But so again, now we've just got the number. If this card number is greater than 10, it's the easiest way to do this. One of the ways I can do it is just with an if it's an 11, then print this. If it's a 12, print this. If it's 13, print this. I'm going to try another way of doing it. Let's see if this is better or worse than that. This might be fewer lines of code, but it might make less sense. I'm going to call it face cards. Create an array that's got Jack, Queen, King, ace. And if it's more than 10, return the item that we want from the array, which will be, if it's 11, we want to return item 0 from the array. So it's this card number minus 11, I think. So in other words, yeah, if this card number is 11, then take 11 off this card number and get 0, which means face cards item 0 will be the jack. If we've got it wrong, it should be fairly obvious when it starts printing out weird cards. Else, just return this card number. In fact, let's then put the suit back on it again. So suit equals, how do you get the last character of a string? Python last character of string. That's not answering quite the question I want. How do you get the last character of a string in Python? Okay, is it just -1 without a colon? I think so. Card -1. So turn this back into a string and put the suit back on the end. And ditto here. In fact, we haven't had to change the card number. We could just return the card. We haven't changed anything. And we don't need an else, because if we haven't returned, we must have the right card number already. What I think I can now do is find places I've used this card and do print card number brackets this card. Let's just do it there, so it's only going to change the first card string. First card is 4 diamonds. Okay, turns out we do need to use it elsewhere in order to be able to see it. Just had an idea for how to make it easier to see this without having to rely on the randomness. What we will do very quickly is if we change this to this card in deck and use the completely unshuffled deck, we now know exactly what order the cards are going to come out in, because it's the unshuffled order. Why is the first one a 7? What? That's really confused me. I think this is something to do with how global variables work. I think in calling shuffle deck, it still shuffles the original variable. So what I'm going to do instead is comment out this line, so we never even try and shuffle the deck. Now what we might have is an unshuffled deck. There we go. These things make sense, they're just a headache sometimes. So I'm just going to keep saying higher. So we've got 2 of spades, 3 of spades, 4 of spades, 5 of spades, 6, 7. So now we're going to check whether our jack, queen and king is correct. 10, higher than that is the jack, and it has detected that it's higher. Then it's a queen, then it's a king, then it's an ace. Then we're going to go lower, because it's the 2 of hearts. I must have hammered through that too quickly. I managed to get a string wrong. I have to go back and pause the video and work out how I lost that. I think I must have pressed 2 letters or something. It's to do with the fact that I didn't validate my input and it took a bad input at some point. Most likely I hit enter without entering a higher or lower, and it took an empty string and then said, oh, you predicted empty string. That's why the next thing on the to-dos would be to validate the input. Let's say the stuff that remains, hang on, let's take the shuffle deck. Let's reshuffle the deck. Let's have 3 rounds of this, 3 attempts to get to 10 cards. I think 10 cards is pretty ambitious, to be honest, but let's Okay, I've also just noticed I managed to type a H up here. My laser eyesight noticed that. So one of my times when I was trying to play that last round, I must have ended up typing in here for some reason. So I'm going to have 3 rounds. See how close to 10 cards in a row I can get. And then I'll go and do some refactoring. Oh. This card in shuffled deck. Ah, no, I meant shuffled deck rather than shuffle deck. I'm going to add to my to-dos as well. Change how the initial shuffle works. It looks like I don't need to call 2 functions. It will just... I mean, I could, for a start, I could just stick this random shuffle in create deck, so it always creates a shuffled deck. I just thought it might be nice to be able to create an unshuffled one at some point in the future, but it does look like that is modifying the original deck, so we don't really want to do that. So, anyway, 3 rounds. Okay. Pretty happy with a 5. I'm going to go higher. It's a jack. I'm going to go lower. It's a 7. Last one I went higher than a 7. Again, I feel like you should always play the odds. I could even have like a cheat mode that writes out what the odds are. There are more higher than lower, so let's go higher. It was a 4. I got 2 in a row. Second game. 9, lower. 5, higher. 1 in a row. Final attempt. Higher. Queen, lower. Jack, lower. Oh, for God's sake, 2 in a row. I'm going to have one more go. I'm not happy leaving this only getting 2 correct in a row. 5, higher. This is a really hard game. Anyway, it's there. The script is there, and I'm going to put it in the episode description so you can see, first of all, what I did in this video. I'll leave that version, the kind of raw, unfinished version in there so you can pick it up from there. I'm also going to do a complete refactor now off camera, and there'll be a nicer version in the description, which is my refactored version, which will have the same functionality. I will probably add the input validation, because I think it's probably only 1 line to just check the value of next card prediction and just loop around until we get a valid value. And yeah, also I'm going to attach a screenshot of me eventually getting 10 in a row correct. But that's it for this episode of Let's Explore. A little harder than the last Python experimentation because we were trying to do more things. We're doing some comparisons of values. We have to do lots of switching values between being strings and numbers. So lots of this string conversion and int conversion. Some clever things around arrays. I'm going to think about whether I want to refactor how this card number creation works, but that doesn't look terrible. And yeah, I'll see you all next week. Thank you very much for watching, and please like and subscribe. My Twitter account is @NeilStud, where you can find more about what episodes are coming up. And if you'd like to give feedback on what's coming up, please leave a comment below. Thanks a lot, and see you next week. Bye.